Hello, everyone. This is the first series of Beyond Literature presentation. I may be doing this presentation multiple times, but this will be my first attempt. And Beyond Literature meaning is a science that we will try to do things differently. Let's start with what is the traditional way. It makes sense once you look at it. We start with motivation and look at what else has been done before, and then we look at the method that we are doing, what is new in our method, and then show that our new method is doing some improvements on the prior methods, right? This is typically what has been done, and this makes sense mostly, but there are some problems currently what we are facing, especially I think the communication aspect. Now people are trying to publish papers, and more papers are coming because large language models allowing to write papers, and they look like each other, and sometimes they do not make sense. In some cases I have seen some papers, even the topic is irrelevant for what they are citing, for example. But like there are some growing interest for people doing writing for the sake of writing, and that causes that reviewers are not much interested in uh, reading those papers anymore because of the overload, and also the quality decrease in the quality. And right now that kind of approach is also increasing the imitations, like the similar things, small changes, and showing improvements comparing the baselines. But high risk topics are not yet discovered. Like it's difficult for a reviewer to understand the things that is outside of the scope, and there is no motivation to do the discovery projects because it's not rewarded immediately. It takes long time, and also complexity is somehow rewarded. Like it is difficult if the paper is more difficult to understand, it's more promoted, uh, because the simplicity is kind of giving the superficial understanding, um, giving the superficial work. But on the other hand, in the practice, it is not happening that way. Like simple things usually wins in practice. And also we are also having too much formalities, and also having the paywalls in the publication process. So these are all current system is having some problems. That what we want to do, if we come back to the science, right, what we want to do is discover something and share with other people. And there are some better communication tools. This is one communication tool that I'm using right now, for example. And we can create videos and development, showing the development process. We can create html applications, the paper itself having demonstrating the, for example, the internal of neural networks and other things. So there were some attempts before, but no widespread adaptation right now. People are still using pdfs, the old pdf styles, trying to write the codes with latex, which is pretty outdated right now. We shouldn't use them. We should use HTML. That's one of the beliefs that we are having right here. Also, we should embrace the open discovery. Sometimes, uh, I mean, we are not doing uh, for the end goal, but we try to follow our curiosity if something could be done, and try to do things that are different than what has been done before. So for that purpose, we will be starting with the Web 3.5 operating system case study. This is a science discovery because there is no trial before to obtain such kind of operating system. There are some studies, I would say, has some resemblance. I will come into the prior section later. But first of all, let me describe what it is. It's a new type of operating system. It's a distributed operating system that brings multiple computers into single virtual computer using the front end technologies only. Like, we don't have to install anything into your computer. You can combine multiple computers into a single computer. And mostly right now, since this is the discovery process, and we will be trying to understand how we can do that, and mostly advanced level trials will be over there. And but time to time we are hoping that we can share the summarization of the results, and then now we will be able to start. Okay, let me describe what aspect more. What aspect? We want to combine multiple computers in the front end, communicate them, and allow them to have storages, RAMs, and also computational units together so that they behave like a single system. And this could allow us to do scaling. It will be something like file sharing, you can consider single file system across multiple computers, and we will handle those synchronizations using peer-to-peer communication. So it could be either public network or private network that you can decide, and it will be completely browser based, so you just need to enter the URL to join to the cluster. We don't need any additional installation that we are hoping for. And it's considered as also IoT system. Why it's an IoT system? Because you can have small devices like that they're combined and decentralized manner. You can have a single system that does the Internet of Things. These are the things, right, that we are saying. And and we are focusing on simplicity. We want to make it step by step in a slower pace, so it's not a high demand, let's say, stream right now, but we would like to discover what is possible out there, and can we develop such kind of operating system on browsers. So yes, why we are doing that? Because we want to combine multiple computers. We are having more and more computers. Even you can, if you can consider your tablets and phones, there are more than enough computers in our daily life. And sometimes the old computers are not used. But sometimes we want to be synchronized, right? Maybe we want to scale something, or we want to utilize, and maybe simplifying synchronization of files or distributed computation, allow mobility between devices, I mean, where you left, and these kind of things maybe will create some useful outcomes out there that we are hoping for. But as I said, this is kind of a discovery process. Another thing that comes as a use case, as an idea, is liquid computing. You may know that cloud computing is the way that people are doing scaling right now. They can use hundreds of computers for their computational tasks, but they are costly, and there are so many details in cloud computing that it is difficult for users to use, and sometimes there could be errors that can cause costly mistakes. That is why, if we can have our own system of scaling, that will maybe simplifying some of the things. For example, if we have a bucket like that, and if you put something Internet of Things devices into this bucket, they will connect to each other, and while they are connected, they will share their storage and also computational power. So if you need more computational power, you add more devices into this bucket, and automatically it connects and shares the power, so that you can scale easily, and you can share your computational units with other people, and you can sell buy new computational units. That's what we are hoping for. So you also, there is another analogy that we can have here, right? You can have docker containers and running around in the clusters, and this kind of small devices could be running those things. but instead we are doing a simplification, the virtualization that we are doing in the front end completely, and hoping that they will become like a single computer. So if you just add one more device into your bucket, you should have more powerful device at the end without changing anything. That is what we are hoping for. Another thing, once we have established this kind of operating system, you can make your cluster a public one, that having peer-to-peer communication would allow you to create some websites without doing any hosting services. So you can just create your cluster, make the URL available, and the URL could be shared from one website, for example. And then once the URL is available, some other computers could connect and sell and buy digital goods. We are naming the currency for this digital service buying and selling things using time crystals. Time crystals. So if you are spending some time and creating some content, maybe if that it is saving some other people's time, then it should be a time crystal. So currently, this is completely experimental, as I said. So it's not a real marketplace, but it could be peer-to-peer marketplace at the end. So another thing, like as I said, right now it is kind of a science that LLM is transforming the jobs. Previously, the machinery and automation transformed to blue collar workers. We are having knowledge workers. Now, knowledge workers need to be changed as well. Knowing only is not sufficient. Now, there is a new type of workers. I don't know if the color selection is good, but I would say green collar workers, meaning that discovery workers. You try out things which LLMs could not do, and you come up with new ideas, test the ideas, debug the ideas, and we will be doing this kind of thing here in this channel. And we don't know the outcome, so it could be turning out to be a social network. It could turn out to be a communication tool like some existing communication systems, or it could turn out to be a file sharing mechanism, or it could turn out to be a marketplace, but it could be on anything else as well. But right now what we are naming as operating system 3.5 operating system, Web 3.5 operating system. And how we will implement that, there are existing technologies we can use that. WebRTC, and there is a peer.js library. Peer.js library allows JavaScript websites purely on HTML pages to communicate with each other. And then we have the IndexedDB for the local storage. You can treat this as a file system, and if you synchronize these index keys between the devices, then it becomes a distributed file system. And there are existing machine learning models makes things more intelligent. We will build things ground up using the machine learning. Maybe some decision processes will be based on those large language models, but we would like to keep these things small as possible and portable as possible. We will experiment things around that, but let's see what will turn out to be. And completely browser based, no backend is necessary, and it is a new type of virtualization and operating system. And we will have some computational benchmarks to see what is the power of each CPU, so that it can decide intelligently to distribute the tasks based on this latency, and then floating point computation capacities. And with the help of LLMs, we will be developing JavaScript code faster than before. Previously, it was difficult to write an operating system. Right now, with these large language models, it will be easier. Uh, Also, because they are seeing so much amount of JavaScript code as opposed to some backend code. Front-end code is always in the front-end. Web crawlers are collecting that kind of data, and those data sets are stored to train the large language models. So that's why we are expecting the large language models to perform better on JavaScript. It may be a wrong hypothesis, but it's open for discussion. Okay. For whom currently, for enthusiastic tech people, and it is high level, as I said, but I would like to do the summarization time to time. And maybe we will see so many debugging boring systems. Actually, this content may be a useful thing for large language models as well. So maybe it's a training data for a development process for ourselves as well. So we will understand our content back, and then maybe create transcriptions and find the corresponding locations, and it will be somehow different development than what we have seen before. And yeah, it requires software development background. I will be publishing things here in this YouTube channel, and see how the process would be. And just a quick note, prior work exists, and I know some of them. uh, PyScript is a nice tool, for example, that allows to run Python on browsers. That is uh, one possibility that we can use as well, but it's not an operating system. There is a Web3 operating system which is running Linux on Web3 environment. However, it is clone of Linux. It's not a new type of operating system. So we are looking for new type of operating system that is distributed and virtualized for making new kind of use cases and allowing users to define their own clouds, for example. And also, I mean, there are cluster Kubernetes Docker based systems doing the virtualization, which allows scaling as well. But as I said, these are different, and the virtualization in not in the level that combines multiple computers, instead allows scaling for new tasks with the replications and this kind of stuff. Yeah, so thank you for watching, and we will see again. And I would like to tell at the end, we are human. We will discover, let's be more human.